All right, we're going to continue on this Unit 1 Trig packet. So we finished through the table for example 1. Now we're going to start talking about a couple of formulas. And the first one is finding the arc length of a circle. So we all know to find the circumference of a circle, the distance around a circle, you use this formula. But we don't want the distance all the way around the circle. We just want a partial distance, a sector distance. So this distance right here. So it's kind of the same formula. So for the circumference, the 2 pi is the angle in radians all the way around the circle, and you multiply that by the radius. So we're going to do the same thing for the arc length formula. We multiply the angle of the central angle by the radius, and that gives us the arc length, but it's just a partial circle, not the entire circle. All right, and then a couple of years ago, someone shared something with me that science teachers do, I think Mr. Higdon. Whenever it's a formula like this where you multiply two things to get another, what's by itself on the left side, you would put up here on the top, and then the two things you're multiplying go underneath. And if you want to find S, you're going to multiply R times theta. But then if you want to find something else, you're going to divide. And then what you do is just figure out, like, cover up what you're looking for. So like if you were looking for theta, you would just kind of cover up theta, and that would mean you would divide S by R. Right, so I kind of like that. If you want to use it, you can. Otherwise, you can just use the formula from the box. All right, so for example 2, we're going to find the arc length of a circle or an arc with radius 4 inches and theta 60 degrees. Now, it is important that your theta is in radians. If your theta is in degrees or revolutions, we do need to change it to radians. So let's do that first. So if we want to change degrees to radians, you multiply by pi over 180 degrees. Okay, so the 0 and the degree would both cancel out, and you would be left with 6 pi over 18. And then that reduces down to pi over 3. Now you can reduce more as you go if you want to. I'm going kind of slow on that. All right, so once we get our theta in radians, we'll just take our radius and multiply it by that angle. Oops, I wrote the wrong thing. It should have been 3, not 8. Okay. And when we multiply, we'll just multiply across the numerator and multiply across the denominator. And so that's 4 pi over 3 inches. Now the unit of your arc length is going to match the unit of the radius. So inches to inches. Okay. So let's do another one where we're given something different. So on example 3, we know the arc length is 6 inches, and we know the radius is 2. We want to find the central angle in degrees. All right, so that means S is 6 and R is 2. So if we're looking for theta, if we go up to our little circle, we're looking for theta, so that means we take S and divide it by R. So theta is S divided by R, so 6 divided by 2. So theta is 3. So is that 3 degrees? It is not 3 degrees. That is 3 radians. So remember, radians doesn't have a unit. So if you get an angle with no unit, it's radians. If this was supposed to be 3 degrees, somewhere in the problem, there would have been a degree pop up, but it is not degrees, it's radians. So what we'll do is take our 3 radians and change it to degrees. And to change radians to degrees, you multiply by 180 degrees over pi. So it's going to be 540 over pi degrees. All right. And then on this one, we have the arc length and the central angle, and we want to find the radius. So when we're looking for the radius, we divide the arc length by the central angle, or by theta. Now, theta is not in the right unit, so we'll take our 125 degrees and we're going to change it to radians by multiplying it by pi over 180 degrees. Okay, so when we multiply this, we're going to get 125, the degree cancels, pi over 180. I do know that 5 goes into both of those, so I'm just going to go ahead and reduce by 5. So it's 25 pi. And when you take 180 and divide it by 5, you get 36. And then 25 and 36 don't have anything in common because the only factors of 25 are 1, 5, and 25. 1 doesn't. 1 is common with everything. We don't use it to reduce. So that's it. That's the reduced version of theta. So we're ready to find r by taking our s, which is 2 meters, and dividing it by our theta in radians, which is 25 pi over 36. I'm going to mark that 2 out because it's kind of floating around there. Okay, so if we want to divide by a fraction, we're just going to multiply by the reciprocal. Now, if it helps you to write 2 over 1, you can. It's up to you, but we're going to multiply across the numerator and across the denominator, and that is our answer. And the units match the units of the arc length, which is meters. All right. So let's do one more, and then we'll talk about another formula today. So for 5, we want to find the arc length of an arc with a radius of 3.5, let's say 3.5 miles. I forgot to put the unit here. It's a really, really big arc. And theta is 100 degrees. Okay, so theta is not in the form we want it to be, because if we tried to use degrees in this formula, we'd end up with like degree miles, which doesn't even make sense. So we have to change it to radians so it won't have a unit at all. So when I do my multiplication, I just end up with miles, not degree miles. Okay, so it gives us 10 pi over 18, which reduces to 5 pi over 9. Now, I know for arc length, we're looking for arc, we're going to multiply s times theta. So I would multiply a decimal times a fraction. I put a little note there that it's not good to leave a decimal inside of a fraction. It's just weird. So if you can, like if it's easy to do, go ahead and change 3.5 to a fraction. Multiplying 2 fractions together is better than multiplying a decimal times a fraction. So I would change my radius to 7/2 miles. So now when I find s, I'm multiplying 7/2 times by pi over 9, which is going to give us 35 pi over 18 miles. All right, so that's arc length. Now the other formula we're talking about today is the area of a sector. So hopefully we all know that the area of a circle is found by pi r squared. So we can still take that formula and change it so we can just find the area of a partial circle, a sector circle of a circle, like a slice of a pizza is what I think of when I think of a sector. So remember, 2 pi is the angle in radians for a full rotation, a full circle. So that's kind of like this, except that's half of the angle. So we would do the same thing for the circle. Half of the angle multiplied by the radius squared is going to give us the area of a sector. Okay, so we're going to, on the first one, find the area of a sector with a radius of 8 centimeters and a central angle of 75 degrees. So again, we don't want to get degrees square feet or degrees centimeters. So we do want to make sure we change our angle to radians because radians has no unit. Okay, so the degrees are going to cancel out. And so we would get 75 pi over 180. I know I can reduce those by 5. So we get 15 pi over 36. And that will reduce one more time by 3. And so we get 5 pi over 12. Okay, so for the area of a sector, it's 1/2 times that angle. Oops, I wrote the wrong one. Times the radius squared. Okay, so I would just multiply across my numerator. So 1 times 5 pi times 64 is going to give us 320 pi. And then across the denominator, 2 times 12 is 24. All right, and then that will also reduce more. So I know 2 goes into it 4, but the largest number that would go evenly into both of those, I would say, is 8. So divide the numerator by 8, divide the denominator by 8, and then for area, because I squared the radius, I end up with square units, so square centimeters. All right, and then I do have a couple of application problems on here. So your application problems on your assignment are kind of mixed up. It's not like this one you do arc length, this one you do area. You have to read it and figure it out, but it's not too terrible to figure out. So for example 7, a sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through at an angle of 120 degrees. Find the area, that's kind of a big hint of which one to use, of the fairway watered by the sprinkler. So the sprinkler creates a sector when it sprays, all right? And then that angle is 120 degrees, and that R, the radius, is 70 feet. So we want to find the area that's being sprayed. So first, and as always, we don't want our angle in degrees, we want it in radians. Okay, so a 0 and a theta, a 0 and a degree will cancel out. So we're left with 12 over 18. And 12 over 18 can both be reduced by 6. And I get 2 pi over 3. Okay, so don't forget that the area of a circle, the area of a sector is found by half of the angle times the radius squared. And we could say the area of a circle is found that way. It's just that whole angle is 2 pi. Now on this one, I would just go ahead and reduce. We haven't been like cross-reducing throughout these, but when I see a 2 on the denominator and I see a 2 in the numerator, we're multiplying, I would just mark those out. That's just smart and just time-saving work right there. So in the numerator, I'm multiplying pi times 70 squared. Well, 70 squared is 4,900. And then when I multiply the denominator, it's just a 3 down there. And because we're finding area, the unit is in square feet. Okay, so one more to go. On example A, the pointer on a voltmeter, I think that's how you say it, is 6 centimeters in length. You can see it on the figure. Find the distance of the tip of the pointer if, I don't know, this is worded weird. If the angle of rotation is 20 degrees. So we need to figure out if we're finding an area, if we're finding an arc length. And this is definitely an arc length. We want to find a distance that it traveled in a round way. That's an arc length. All right, so the arc length formula, we're just going to multiply the radius by the central angle in radians, which we don't have that yet. So we'll take our theta and change it to radians real quick. So 0 and a degree cancel out. 2 over 18 is going to reduce to 1 over 9. So our theta is pi over 9. All right, and then we'll just take that and multiply it by the radius, which is 6 centimeters. Okay. So 6 pi over 9 is going to reduce to 2 pi over 3. And that unit should match the radius unit exactly. All right, so what I want you guys to do for your assignment is number 2. Now on number 2, you're given 2 things and you're finding the missing things. So on A through C, you're looking for the arc length. On D through F, you're looking for the angle, and then it tells you if we want which version or unit we want the angle to be in. And then on G and H, you're looking for R. Now, there are 2 angles in the theta column that don't have a unit. So we have 1.5 here and we have pi over 3. So if there's not a unit on your theta, then what is it in? No unit means this is already in radians, which is awesome because then that's one less step that you have to do. So keep that in mind. All right. And also be careful on F. So pay attention to the units on F. All right. And also I would on this theta column is if the angle is not already in radians, just go ahead and use this space to change it to radians. That's what I would do. That's what I did when I worked it out. Okay. And then also finish page 5. So it's doing a couple of area of sector problems and then some application.